Hello students and learners, welcome to the Brainbox tutorials. I am your teacher Priyanka and today we will solve specimen question paper of I.C.S.E physics of semester 2 examination. Okay, and we will discuss the exam pattern also and then we will solve this whole specimen paper. So let's start. Physics semester 2 paper will be of 40 marks and time allowed will be 1.5 hours. You will be given two sections, sections A and section B. We will have to attempt all questions from section A. So there will be 10 subparts of question number 1 and those 10 subparts will carry 1 mark each. So total of 10 marks. And from section B, you will have to attempt any 3 questions out of 5 questions given. So 3 questions for 10 marks each, so that will carry 30 marks total, 30 plus 10, 40 marks paper. Now let us start with solving the paper. So we will start with section A, question number 1, subpart 1. Question is, pendulums A, B, C, D are tied to a flexible string PQ and are at rest. Pendulum C is disturbed, this one. Which of the following statements is true? Now 4 statements are given. First one is, only pendulum C will start vibrating. No. Number B, pendulums A, B and D will also start vibrating, but A and D will vibrate with the maximum amplitude. Yes, this one is the correct option, number B, because if C will be disturbed, then all the other pendulums will start vibrating and A and D will vibrate with maximum amplitude because of resonance as they are of same length. Subpart 2. Which of the following is not a characteristic of parallel combination of resistors? Okay, let's see. Number A. If one resistor is fused, the circuit does not become open. Let me make one parallel combination. Let's see, from point A to point B, there are 3 resistors, 3 ways with which we can move from A to B. Now here, number A, it is written, if one resistor is fused, let's say number 1 resistor is fused, the circuit does not become open. Yes, that is right, still the circuit is closed. Number B, the total resistance R is given by the formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. That is also correct. Number C, the total resistance becomes less than the least resistor present in the combination, which is also true. And number D, the current through each resistor always remains the same. This is not a characteristic. Current will not be same, current will be different according to the resistance in each resistor. Number 3. Which one of the following statements is correct? Number A. Live wire has 0 potential. No, this is not true. Actually, the neutral wire has 0 potential. Number B. Fuse is connected in a neutral wire. No, that is connected in a live wire. Number C. Potential of live and earth wire is always the same. No, this is also wrong. Number D, earth wire is used to prevent electric shock, which is correct. So, number D is correct. Number 4, the diagram below shows a free conductor AB is kept in a magnetic field and is carrying current from A to B. To avoid confusion, complete path of the circuit is not shown. Okay, the direction of the force experienced by the conductor will be. So, we will have to choose the direction of the force on the conductor, whether the conductor will move upwards, downwards, towards north or towards south. So, we will use here Fleming's left-hand rule. If this is the magnetic field from north to south, which is written here, and this one, the middle finger is showing the path of the current which is flowing from A to B like this, then the conductor will move upwards according to Fleming's left-hand rule. That means part A, up, is correct answer. Number 5 is, the diagram below shows a magnet moved near a coil along its axis. Which of the diagrams shows correct flow of current during this motion? So what type of diagram given here? That a magnet is there, here it is north pole, here it's south pole, and the magnet is moving away from this coil. If it is moving away from the coil, that means this part of the coil will have south pole, this will have north pole. If this is south pole, that means current will move in clockwise direction. Clockwise direction means from here till here, like this. Okay, let's see which of the diagram has these type of arrows. So we can see among these four options, number C is the one which we have also drawn. Okay, so number C is the correct option. Now moving on to number 6, the meaning of the statement specific heat capacity of water is 4200 joule per kg per Kelvin is. Number A, water needs 4200 joule heat to raise its temperature by 1 Kelvin. Number B, to raise the temperature of water, 4200 joule of heat is absorbed. Number C, 1 kg water absorbs 4200 joule heat to increase its temperature by 1 Kelvin. Yes, this is correct. So option C is correct. Number 7, 200 gram of ice at 0 degree centigrade needs dash heat to melt. Specific latent heat of ice is given 3,36,000 joule per kg. Now what does specific latent heat of ice mean? That 1 kg of ice needs 3,36,000 joule of heat to melt. So if 1 kg, that is 1000 gram of ice needs how much? 336, 1, 2, 3 zeros, joule of energy. Therefore, 200 gram of ice will need 336,000 divided by 1000 into 200 joule, that is 336 multiplied by 200 is equal to 67200 joule. So that is number B. Moving on to number 8, the radiation with maximum penetrating power. Now we know gamma radiation has maximum penetrating power, that means number A, gamma, is correct. Moving on to question number 9, resonance is number A, a forced vibration in which amplitude remains constant. This is wrong. Number B, a forced vibration in which frequency of forced vibration is greater than the free vibration of the body. This is also wrong. Number C, a forced vibration in which frequency of forced vibration is equal to the free vibration of the body. Yes, this is correct. Option C. Now the last part of section A, the nuclear radiation which gets deflected towards negatively charged plate in an electric field is. Now anything positive will be attracted towards negatively charged plate, and in these four options we know alpha particles are positively charged particles, so they will be deflected towards negatively charged plate. So option D is correct option. Starting with section B, question number 2.1 part A. Calculate the total resistance across AB. So for total resistance we see 3 resistors are there. 2 on the upper side are in series and then these 2 are in parallel. So how we will take out the resistance? 3 plus 5, 8. So resistance in series is equal to 3 plus 5, that is 8 ohm. Now resistance in parallel will be, that is 1 by R is equal to 1 by R1, that is 1 by 8, plus this one 1 by 8, that is equal to 2 by 8 is 1 by 4. Therefore resistance will be 4 ohm. Okay, so total resistance across AB is 4 ohm. Now number B, If a cell of EMF 2.4 volt with negligible internal resistance is connected across AV, then calculate the current drawn from the cell. Now we know the total resistance and also the potential difference. So by using Ohm's law, V is equal to IR, we can find out the current, that is I. So I is equal to V by R, or 2.4 upon 4, 24 by 40 is equal to 0.6 ampere. This is the correct answer. Now part 2. Number A, which will absorb more heat? 10 gram of ice at 0 degree centigrade or 10 gram of water at 0 degree centigrade. So the correct option will be 10 gram of ice at 0 degree centigrade will absorb more heat, because the heat energy is used here to increase the molecular separation between the molecules of ice. And you can also write the difference between the specific latent heat and the specific heat capacity of water. That specific latent heat of ice is 336,000 joule per kg, but the specific heat capacity of water is 4200 joule per kg per Kelvin. That is less than the specific latent heat of ice. Okay, number B is, for the same mass of ice and ice cold water, why does ice produce more cooling than ice cold water? So the answer of this will be that ice produces more cooling than ice cold water because the specific latent heat of ice is more than the specific heat capacity of water. That means ice absorbs more heat than ice cold water, and if a thing is absorbing more heat, that means it is cooling more the surrounding areas. Moving on to question number 2, part 3. The diagram below shows an insulated copper wire wound around a hollow cardboard cylindrical tube. Answer the questions that follow. Number A, what are the magnetic poles at A and B when the key K is closed? So if you imagine that key is closed, so according to the cell here, this is positive terminal and this is negative terminal. So the current will move from here like this. So from A, it is moving like this. So if we see at A, the current is moving anti-clockwise. That means this is north pole and this is south pole. So here it is written what are the magnetic poles at A. So at A it is north pole and at B it is south pole. Number B, state 2 ways to increase the strength of the magnetic field in this coil without changing the coil. Without changing the coil, we can increase the strength of the magnetic field by inserting a soft iron bar inside this hollow cylindrical tube, and secondly by increasing the current in the cylinder by increasing the potential difference of the cell or by increasing the batteries, or third option is also that by increasing the number of turns in the coil around the cylinder. Number C, if we place a soft iron bar at the center of the hollow cardboard and replace the DC source by an AC source, then will it attract small iron pins toward itself when the current is flowing through the coil? See, if a current is flowing through a coil, it also creates magnetism. That means magnetic field is created. So whether a DC source is there or AC source is there, because current is flowing, because in AC source, the only difference between DC and AC source is that when a current is flowing through a DC source, the poles are same always. But the poles keep changing in AC source. So still the current is flowing. That means though the polarity are changing, but the part here is still a magnet. It is behaving like a magnet. So here it is written, will it attract some small iron pins toward itself? Yes, and you will explain why. because a magnetic field is created, and that is still created even if AC source of current is there. Now moving on to question number 3, part 1. The diagram below shows a cooling curve for 200 gram of water. The heat is extracted at the rate of 100 joule per second. Answer the questions that follow. Number A, calculate specific heat capacity of water. So, calculate specific heat capacity of water. We have a formula of heat. That heat is equal to mass into specific heat capacity into change in temperature. So, with that we can calculate specific heat capacity, that is equal to heat generated upon mass into change in temperature. Okay, now let's see if we have this. So, we don't have heat generated, we will calculate it by the graph. We can calculate it easily. Mass is given 200 gram and change in temperature also we will see through the graph. So here in the graph, see, from A to B the temperature is decreasing, and from B to C the temperature remains constant. That means here the water is converted into ice, so this is change of phase. Because specific heat capacity of water is needed, so we will only calculate the heat generated from A to B. So change in temperature is from 80 to 0. That means see, change in temperature is equal to 80 degrees centigrade minus 0 degree, that is 80 degrees centigrade. Mass is given 200 gram, and now the heat generated for moving from A to B, 640 seconds are taken, and here it is written that the heat is extracted at the rate of 100 joule per second. So in 1 second 100 joule heat energy is extracted. So in 640 seconds, 100 into 640, that means 64000 joule energy is extracted. So this is heat energy. Now we can calculate specific heat capacity of water. Heat 64,000 joule, mass is 200 gram, so we will change it into kg. So 200 upon 1000, sorry, only 3 zeros, 200 upon 1000 into change in temperature, this is 80. So 64,000 into 1000 upon 200 into 80, 2 3 zeros, 3 zeros. Let's cut this also. 8,000, 4,000. So the answer is 4,000 joule per kg per Kelvin, or per degree centigrade also we can write. Now for part B, the question is heat released in the region BC. That means at the time of melting, what is the amount of heat released. So the time is given here. It is from 640 second to 1312 second. That means how many seconds are taken? 1312 minus 640. 872 seconds. Okay, so here it was already given that heat is extracted at the rate of 100 joule per second. That means heat is equal to 100 into 872 is equal to 87200 joule. This is the answer. Moving on to subpart 2, part A. Observe the diagram given below and state whether the bulb will glow or not when we switch on K. So when we will switch on K, that means when the key is closed, the circuit is also closed. So the bulb will glow. So yes, bulb will glow. Okay, number B is it safe to handle the bulb when the switch is off? When the switch is off, that means like this, that the key is open. So it is unsafe actually. So is it safe? No, it is not safe. Number C, give a reason for your answer in B. Now we will give the reason why it is unsafe. As the key is placed in the neutral wire, that means the current will keep flowing to the bulb through live wire. Even if the switch is on or off, the current will move on. That means it is unsafe to handle the bulb because it may give us shock. Okay, now moving on to subpart 3. Two metals A and B have specific heat capacities in the ratio 2:3. If they are supplied same amount of heat, so they are supplied with same amount of heat. So let's say it is H. So then number A, which metal piece will show greater rise in temperature given their masses are the same? So the masses are same, the heat supplied is also same. So which metal will show greater rise in temperature? The metal with lower specific heat capacity. That means metal A. So the answer will be metal A. And the reason we will give it is that because metal A has lower specific heat capacity, that means 1 unit mass of metal A requires less heat to raise its temperature by 1 degree centigrade. So obviously metal piece A will show greater rise in temperature. Number B, which metal piece will have greater mass if the rise in temperature is the same for both metals? Now in this case, rise in temperature is same and the heat supplied is also same. So here also metal A will have greater mass because its specific heat capacity is less. So to rise the temperature of both the metal in the same way, metal A need to have a greater mass. Okay, now part C. If the mass ratio of metal A and metal B is 3:5, then calculate the ratio in which their temperatures rise. So we have the ratio of masses of metal A and B, we have the ratio of their specific heat capacity, and we know that the heat supplied is same for both of them. So let's take out the ratio in which their temperature rises. Now we know this formula, that heat is equal to mass into specific capacity into change in temperature. Now for change in temperature in metal A, the formula will be heat supplied to A, because they are same, that is why I am only writing H, mass of A multiplied by specific capacity of A, and for B I am writing here, and for B, that is change in temperature in B, will be heat supplied upon mass of B into specific capacity of B. Now we will have to take out the ratio, that means change in temperature A upon change in temperature of B is equal to heat upon mass A into Ca divided by heat upon mass B into Cb. H is same, that is why it is cancelled. Now the answer will be mass of B into specific capacity of B upon mass of A into specific capacity of A, that is equal to mass of B upon mass of A into specific capacity of B upon specific capacity of A. That means ratio of their masses multiplied by ratio of their specific heat capacities, and we have both. Ratio of masses of metal A and B is 3:5. Here B to A, that will be 5/3, and similarly specific capacity of B to A 2:3, so we will write 3:2. So the ratio will be 5:2. Now part D is, if specific heat capacity of metal A is 0.26 joule per gram per degree centigrade, then calculate the specific heat capacity of metal B. Now we have the ratio of their specific capacity, that is 2:3. That means specific heat capacity of A upon B is equal to 2/3. A is given, so that means 0.26 upon specific capacity of B is equal to 2/3. Now by cross multiplication we will have I am writing it here. Specific heat capacity of B will be 3 multiplied by 0.26 divided by 2, that is 0.39, and we will put the unit, that is joule per gram per degree centigrade. This is the answer. Moving on to question number 4, 1 part A. Which one of the following graphs A or B shows free vibrations in vacuum and which one shows free vibrations in a medium? So by looking at the graph, we can see that the amplitude here is same in graph A, but here the amplitude is decreasing as the time passes. That means graph A shows free vibration in vacuum and graph B shows free vibration in a medium. Question number B is, how did you come to this conclusion? So we will write the same thing which I have said just now, that the amplitude of the wave in graph A is constant as the time passes. That is why it is free vibration, and amplitude of wave in graph B decreases as the time passes. So this is vibration in a medium. Question number 2, part A is, state the Faraday's laws of electromagnetic induction. So there are 2 laws of Faraday of electromagnetic induction. Number 1 is, whenever there is a change in magnetic flux lines with a coil, an EMF is induced. And the second one is, the magnitude of EMF induced is directly proportional to the rate of change of magnetic flux linked with the coil. Part B is, name one electrical device which works on this principle. So the answer is AC generator. AC generator. Now moving on to part 3, a nucleus X emits an alpha particle. So subpart A question is, what will be the atomic number of the daughter nucleus Y? Now see, in X the mass number and the atomic number are given, and one alpha particle is emitted. One alpha particle, that means 4 mass number and 2 atomic number is reduced. So Y will be, see, we can write here X 19482. Now this has emitted, so Y will be 194 minus 4 and here 82 minus 2. That means Y mass number of Y is 190 and atomic number is 80. So here the question is, what will be the atomic number? So atomic number is 80. What will be the number of neutrons in the daughter nucleus Y? So number of neutrons plus number of protons is equal to mass number, and we know the number of proton, that is equal to atomic number. So number of neutron is 190 minus 80, that is 110. So number of neutron is 110. Now number C, write a nuclear reaction showing the emission of this particle. So if we will have to show it neatly, we will show like this. Alpha particle is released and Y, that is 190 and 80. Or you can show this one over here also. So plus alpha particle 42, like this also you can write. Now moving on to question number 5, part 1, subpart A. Name the electrical appliance shown in the diagram below. This is a fuse or electrical fuse. Number B, name the material of the wire used in this device. An alloy of lead and tin. And part C is, name 2 important characteristics of this wire. So 2 important characteristics. Number 1 is low melting point, and second characteristic is high resistance. That is why this particular material is used. Moving on to question number 2, part A. Define pitch. So the definition of pitch is that characteristic of sound by which an acute or a shrill note can be distinguished from a grave or a flat note of same loudness. Part B is two wires AB and CD of same length are stretched by same amount. Which wire will produce sound of greater pitch on plucking? Here we can see these are the two strings AB and CD, and AB is thinner, CD is thicker. So the wire which is thinner will produce sound of greater pitch. So AB will produce sound of greater pitch. And in part C, we will have to give a reason for your answer. So the answer will be that AB is thinner than CD. That means it is in high tension and it has a greater frequency. And we know that pitch is dependent on frequency. More the frequency or more the tension, more will be the pitch. That is why AB will have a greater pitch. Now part 3, subpart A. Why is water used as a coolant in radiators of a car? The answer to this will be water is used as a coolant in radiators of a car because it extracts more heat from the surroundings without much rise in its temperature because the specific heat capacity of water is high. Subpart B is name the radioactive isotope used to find the age of fossils. Name the radioactive radiation which it emits. So the radioactive isotope used to find the age of fossil is carbon 14 or C14. And for the second one, name the radioactive radiation which it emits. So that will be beta radiation, because beta radiation is emitted in carbon dating. Now moving on to our last question, question number 6, subpart 1. A beam of alpha, beta and gamma rays is traveling through a certain region in space. Number A, arrange them in ascending order of ionizing power. So in ascending order of ionizing power, in alpha, beta and gamma, alpha ionizes the most, that means it will be put in last, and gamma radiation, they ionize the least because the speed is very high. So ascending order, first gamma, then beta, then alpha rays. Part B is which of the above will pass undeviated if subjected to an electrical field. So the gamma rays pass undeviated because they have no charge. Number C, with respect to your answer to part B above, what will be the change in the nucleus of an atom after such a ray is emitted? So the nucleus of the atom has no change in the mass number and atomic number during gamma emission. So the gamma rays takes no mass and no electrical charge from the nucleus. Now part 2, a change in amplitude of a sound wave is noticed. Number A, which characteristic of sound is affected due to the above change? So change in amplitude affects loudness. So loudness is affected. Part B, how is amplitude related to your answer to part A above? So the answer to this is loudness is proportional to the square of the amplitude. So that is, you are going to write loudness is proportional to the square of its amplitude. That means loudness proportional to amplitude का square. Subpart C is what happens to the quality of the sound. So the quality of sound does not change because quality is dependent on the waveform. Now question number 3. An electric bulb is rated 240 volt 100 watt. Number A. What information can you get from the above statement? The above statement gives us the information that when electric bulb is put at 240 volt of potential difference, it consumes 100 watt of power. Part B is what will happen if this bulb is connected across 220 volt. So the bulb, it will consume less power, and we can calculate it also how less power. See, there is a formula to get resistance. R is equal to V square by P. That means 240 into 240 upon 100. So 24 into 24, 576 ohm. So power is equal to, now if we calculate V square by R, keeping the resistance same, now the voltage is 220. So 220 multiplied by 220 divided by the resistance, that is 576. Let's cut it with 4. Again with 4. That is 55 multiplied by 55 upon 36. That is equal to 84.02 watt. That is less than 100 obviously. Okay. Number C is calculate the resistance of the bulb. So here we have already calculated the resistance. Resistance is equal to V square by P, 240 into 240 by 100, and we will get the answer. Number D. Also find the energy consumed by the bulb in 10 minutes. Energy consumed by the bulb in 10 minutes. See, so electrical energy, if we calculate it in kilowatt hour, the answer will be kilowatt into hour. Kilowatt, that is 100 watt is there. So 100 watt is converted into kilowatt divided by 1000 into hour. Here 10 minutes, so 10 minutes is converted into hour, 10 upon 60. This is electrical energy in kilowatt hour. 1, 2, 3, 1, 2, 3. That means 1 by 60 kilowatt hour. Either leave it like this, or if you want to change the energy into joule, so we will multiply this with 3, 6, 1, 2, 3, 4, 5 zeros, because 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. So cut it. 6, 6 are 36, 1, 2, 3, 4, 1, 2, 3, 4 joule. So either write the answer 60,000 joule or 1 by 60 kilowatt hour. So with this we have come to the end of our physics specimen paper for I.C.S.E. semester 2 examination. I have solved almost all the major papers of semester 2 examination, specimen papers. Go through the pattern of paper and the explanation very closely, and if you like it, please hit the like button and also share it with your friends. Do subscribe to my channel and enhance your knowledge with such worthy videos. So until we meet again with new set of videos and new set of knowledge, keep learning, keep practicing. Bye bye. Jai Hind.